All right, today we're going to go over the average rate of change, and which is part of a larger lesson on the composite functions, which is just a way we can combine functions, also known as the algebra of functions, and that's what we're going to discuss today. So average rate of change right here is basically an average slope. So let us begin by finding a formula for the average slope of the function graphed below. So just kind of a generic function right here. And we're going to try and find the average rate of change. That is the average slope. So we'll just pick a point right here, just kind of arbitrarily. And we're going to pick that one also arbitrarily. And we're going to call this is our, I guess it's not so arbitrary because we have our points given here, right? A is 1, H is 3. So this would be A plus H, right? Because 1 plus 3 is 4. And so now we've got our line segment right there when A is 1 and H is 3. All right, so what is f of A? Well, f of A there is f of 1, and f of 1 is 0. Now we do f of A plus H. That's 1 plus H, right? That's 4. So we're asking what is f of 4? And f of 4 is 2. Okay, so we're going to go ahead and plug all that in down here. This is our average rate of change formula. Note that this right here is delta y, that is the change in y, divided by the change in x, right? Because the change in x is 3. Change in y is f of a plus h minus f of a. So we're really doing f of 4 over f of 1 all divided by 3, because that's the value of h. F of 4 is 0. F of 4 is not 0. F of 4 is 2. F of 1 is 0, though. And then, of course, we've got 3 in the bottom. So this leaves us with 2 over 3, 2/3, right? 0.6 repeated if you prefer the decimal approximate. Right? And the little bar above the 6, of course, means it continues on indefinitely. So we've been calling this the average slope, and that is a perfectly fine way to think of it because that is exactly what it is, but it has a formal name, and the formal name is the difference quotient. Like so. And again, note that this difference quotient is just the average slope. All right, so moving on. So we're going to find the difference quotient of the following. When f of x is x plus 2, we want to find the difference quotient when a is 2 and h is 3. So again, the difference quotient is f of a plus h minus f of a all divided by h. And so f of a plus h is f of 2 plus 3, which is f of 5. And so that is simply 5 plus 2. Note that I'm taking the 5, and wherever I see an x in the original statement, I'm replacing that x with a 5. And so we've got 5 plus 2, and so f of a plus h is the same as f of 5, which is the same as 7. Now we do f of a, and a in this case is 2. And so wherever I see x, I replace it with 2. So I've got 2 plus 2, and that is 4. So go back to our formula for the difference quotient here. F of a plus h, that is 7. And then f of a, which we found to be 4, divided by h, which is given to be 3. And so 7 minus 4 is 3. Divide that by 3, and we find that the difference quotient is 1. All right. Next on the list, we've got a quadratic, x squared plus x plus 1. A is 3, h is 5, and so we're, again, trying to find f of a plus h minus f of a, all divided by h. And so f of a plus h is the same as f of 3 plus 5, which is f of 8. And we plug 8 in, so we've got 8 squared plus 8 plus 1, giving us 64, plus, add the 8 and the 1 to get 9, and then adding these two together to eventually get 73. Now we have to find f of a. And f of a, right, that's the same as f of 3. Plug that in. So we've got 3 squared plus 3 plus 1. 3 squared is 9. 3 and 1 is 4. And so we've got 13 right there. So putting all this together, we've got 73 minus 13, all divided by h, which is 5. 73 minus 13 is 60. And again, we are dividing by 5. And 60 divided by 5 is, of course, 12. And that is our average slope in between the points 3 and 8. Next one, we've got x squared. We're going to find the average slope when a is 3, and then when h is 5, and then again when h is 1, and then when h is 0.1. So first thing we do, we're going to find f of a. And f of a, right, that's the same as f of 3. And so that is simply 3 squared, which is 9. And then f of a plus h. We're going to do something a little bit clever here. We're going to go ahead and replace the a with the 3, but I'm going to leave the h by itself, or arbitrary, I should say, because doing it this way will allow us to just plug in the 3 values at the tail end of our calculation. So this becomes 3 plus h, quantity squared, or 9 plus, and again, we multiply these two together and double them. So that would be 6h, and then plus h squared, right, for an arbitrary h. And now we calculate the average slope. And so we put this guy here first. 9 plus 6h plus h squared minus 9. Again, that's all divided by h. And note here we've got 9 minus 9. Everything else stays the same. But I can factor an h out of the top. So I have 6 plus h multiplied by h divided by h. And of course, h divided by itself is 1. And so 6 plus h is what is left. All right, so h equals 5, right, because that's the first one here. Well, that gives us an average slope of 11. Right? H equaling 1 gives us 7. Right, because I'm just adding 1 to the 6. And then h equaling 0.1 grants us an average slope of 6.1. And note that if I were to continue going smaller, if I, for instance, said a step size, a h or delta x of 0.001, well, then that would end up giving me 6.001. As h gets increasingly smaller, we're approaching an average slope of 6. So what that means is that when the function x squared, whenever we're close to 3, the slope will be about 6.